The following contains excerpts from the Caribbean Educator's Guide to Computational Thinking for Kindergarten to Form 5. You can pre-order your copy at 51books.com. I hope you are blessed by it.
In the rapidly advancing landscape of education, it becomes increasingly imperative to equip primary and secondary school students with a foundational understanding of cutting-edge technologies. Among these, artificial intelligence, or AI, and machine learning, or ML, stand out as transformative forces that have the potential to heavily impact our present and future. As educators strive to prepare students for a world where technology is so pervasive, introducing them to the fundamentals of AI and machine learning becomes essential. This educational journey involves unraveling the meaning behind these terms, delving into their current real-world applications, exploring the vast potential they hold for the future, and engaging in thoughtful discussions about the ethical implications that accompany these powerful technologies. By fostering a nuanced comprehension of AI and machine learning, we empower Generation Z and Alpha to navigate, contribute to, and critically assess the evolving technological landscape. Students who have learned how to read and write conditional statements in computer programming can reference this core computer science concept as they consider the question of whether machines can learn or not. Indeed, conditional statements make it possible for computers to emulate decision-making. The conditional statement structure takes human inputs, such as numbers and words, and passes them through its framework to produce an output. Computational thinking has taken this a step further. Machine learning, ML, employs a variety of models that the machine uses to take inputs and calculate responsive outputs. Classification models are used to sort, categorize, and select. Uses of classification models include grouping customers based on purchasing behavior or sorting email into spam or not spam. Recognition models are used to discern. Practical applications of recognition models include self-driving cars that have to discern an obstacle from open road space, and phone cameras that can discern a person's face from other objects in the field of view to focus on. Reinforcement learning is a reward and punishment model that is used to maximize optimal outputs and minimize unsatisfactory ones towards a known target value. This is most frequently used to teach computers how to play games against human opponents. Unsupervised ML models are pattern recognition-dependent models that analyze data to spot and target anomalies. Use cases include targeting frequent customers or identifying fraudulent transactions. Here's an example of a practical use for the classification model. Suppose we wanted to program a machine to sort mangoes for export. We could possibly write an algorithm containing a conditional statement to yield a binary output: meets standards or does not meet standards. We could simply call these good or bad. Start by asking your class what characteristics they look for in mangoes. This can include ripeness, firmness, color, and lack of blemishes or holes. They can readily answer this question, and once they do, pose the problem. The problem with this is that there are many varieties of mango, and these criteria can vary widely. Some mangoes remain green when they're ripe. Other mangoes naturally have black spots on them that the computer may reject as blemishes. A more effective way to program this machine would be to train it to scrutinize mangoes. Ask the class how they came to know a good mango from a bad one. The two most pertinent responses they can give you would be that someone taught them and that they have been eating them for so long that they just learned over time. Both of these connect directly to machine learning. The ML classification training would happen in stages. First, we might show the machine a lot of mangoes, perhaps by placing the mangoes in front of or in contact with its sensory equipment, and telling the machine if each mango meets standards or not. Then, we might continue to show it mangoes and specify whether each mango is blemished or not. We might repeat this process to teach it how to recognize ripeness and judge firmness. All the while, the computer is adjusting its own algorithms to be able to make better and better choices on its own.
You can guide your students through the process of using their criteria to establish this decision tree. Using computational thinking, students can deconstruct the process of selecting a good mango to eat by organizing their criteria into a reasonable sequence. This will challenge them. In reality, we make these decisions within seconds, and we use little brain power. Nevertheless, it does involve a list of criteria that are assessed in a specific sequence. For example, if a mango is not visually ripe to begin with, you would not bother to check for cuts and blemishes. If a mango is too squishy, you would already know it is ripe. The decision tree illustrates the process by which the machine will use our criteria to sort mangoes. The first question the machine might ask is the mango ripe? After you have shown it a variety of different mangoes that are ripe, the machine should have enough sample data to discern a ripe mango from a green mango. If no, then the mango is considered green. As a response, it can either be left on the tree or picked to make green mango dishes such as chow or masala mango. If it is ripe, then it passes through to the next criteria in the classification process. Is the mango firm? If it's not, then the mango is overripe and can be discarded. If yes, then the mango goes through the next step in the classification process. This final selection process is called skin intact. This checks to see if the mango has bruises, slits, or other blemishes. It looks for worms or anything else that has corrupted the mango. If the skin is not intact, then it is discarded. If the skin is intact, then you may eat it. In your lesson, be sure to connect the decision tree with what they already know about conditional statements and allow them to be mango experts. Indeed, they probably are exactly that, to encourage participation. According to the age of your students and your available resources, you can make the decision tree into a cut-and-stick activity or assign it as a project. Have them classify other items to perform other tasks, such as selecting among drinks in a fridge at the shop. Do I buy a water or another drink option, or sorting the family's laundry? For an on-screen exercise that can help consolidate this for your students, Code.org's AI for Oceans activity can be found at hourofcode.com. Just type AI in the search criteria to locate it quickly. This activity is suitable for tablets and smartphones as well.
If you use these lessons and tips, please give me some feedback in the comments about what age group you taught and how it went. Also, please like and share this video with other teachers and help us empower more educators across the region by subscribing. Thanks for watching. Bye for now and God bless you.